the lesson this week. So we have this worksheet. It's done in the same format as before, green, yellow, and purple. Green, if you complete that, you should be able to complete it in 3 hours or less. Of course, you have major gaps, but some of you are just working your way through the course and you're done here, and you might not be taking science again. And okay, so green is perfect. If you're planning on taking grade 11 science, grade 12 science, yellow it fills in more gaps. As I've said before in many other previous lessons, it doesn't really matter how much you do, you're going to have gaps because of the nature of the learning, but yellow will ensure that you have fewer gaps. It's a more complete overview of the lesson. And then purple gives you elaboration. In this lesson, more so than others, the purple really is an enhancement of the learning. I would not want to see anybody looking at all the purple and say, I'm going to do all of them. That's not how you should go through this course. You go through them, find what you think is interesting. These thought questions at the beginning, that's an easy one for anybody to do, whether or not you're doing green, yellow, or purple. But they are thought questions. They're completely an enhancement to the lesson. So you choose as you see fit. There are a lot of links in this worksheet, and there are some links on the PowerPoint. So you might need to download and open the PowerPoint in order to get access to the links. The end of concept questions. So at the end of this concept, so the end of this week, these are the questions you should be able to answer. And if you're doing green minimum, just answer the questions. If you're looking for yellow or exemplary, then I'm suggesting that you might want to draw out the thermal energy as it moves through the atmosphere and hydrosphere and capture it using a Flipgrid presentation or your camera or whatever, and then submit it however you'd like. And that would put you into a more complete understanding of the concept. As a matter of fact, this is one of the questions I would ask on the test if this were a normal class. There's a number of definitions. Some of these graphics are super small. You're allowed to resize them, but they're also in the PowerPoint full size. As I said, there's lots of video links. You choose which ones, how many of them you'd like to watch. Some of them are short, like 30 seconds, 50 seconds. Some of them are long, like 18 minutes. So I wouldn't watch 18 minutes. I just kind of watch the first minute and a half or whatever I've said. Sometimes I said start at, and so you can watch like a minute or two after that until you're ready to move on to something else. All right, so I'm just scrolling through here. You'll see there's lots of yellow, green, purple. So it's a very colorful worksheet. So you decide, again, what you think is best. As you get towards the end of the worksheet, you'll see a lot of purple. So a lot of places to enhance. The Great Pacific Garbage Patch and convection and thermohaline, Bill Nye the Science Guy video, this ocean elaboration activity where you follow the these rubber duckies that were dumped off a boat in the middle of a storm in the middle of an ocean, and how they moved around the world for the next 25 years. It's really quite an interesting story, but it's purple, so only those of you who choose to go that route will learn about that. In addition to the rubber ducky spill, there's the Nike shoe spill and some other interesting spills that happened over the past 30 years. This final graphic you should be able to interpret at the end of this lesson and explain how that relates to climate change. So that is your worksheet. Your PowerPoint is the same format as you've seen before as well. I've color-coded the slides. So the green slides, so if you take a look at this, let me just make this super tiny. As you look at this, you'll notice that the majority of this is not green. So if you're doing green, the green you should be able to complete in 3 hours or less. It's the minimal information. You'll notice there's much more yellow, and there's quite a few spattering of purple slides in there as well. A lot of the purple are the anecdotes, the stories, the things that make the lesson interesting and engaging. But again, it's June 8th, and you need to decide on how you want to spend your time, right? If you decide that you want to spend your time learning about climate change and then being able to apply these things to next year in your various classes, great, fantastic. Ask me questions. I'm here for you all week long. So that is what the PowerPoint looks like. There are a couple of concepts on here. One in particular that I do want to explain. It's a little bit complicated, and normally I explain it at least twice or 3 times in class. So I'll do this video. And this little video here, it's going to show you how the sun, the ultimate source of energy on our planet, is able to drive geothermic winds that are moving thermal energy around the planet, both in the atmosphere and in the hydrosphere. So think about where the direct rays of the sun hit on our planet Earth. They hit on the equator, right? The equator is kind of that middle spot, right? And so there's the sun. The sun is directly over the equator, and it's heating all that region between the tropics. The Tropic of Cancer is on top, and the Tropic of Capricorn is on the bottom. Anything in between the tropics can receive direct rays of the sun. So as I go to the Earth here, I'm going to draw my tropic of my equator. I'm going to draw my tropic of, well, let's say this is 30 degrees up here. I'm just going to focus on the northern hemisphere. And this is 60, right? So I got 0, 30, 60, and the North Pole is at 90. All right, when the sun is shining down on the equator, this area of the planet, the atmosphere here is very hot. And as you work your way through this lesson, so this particular thing I'm describing here, this will make more sense once you've made it through all the components of climate and understand atmosphere and a little bit of hydrosphere. So you can watch it now to prep you for the learning, and then once you've done the learning, come back and review and it will make more sense. So as the sun shines down the equator, the air here, will it rise or will it fall? At this point I'm listening, you guys are all saying, oh, well, since there's no one else to hear you, you're probably a little bit more vocal with your answer. Hopefully you said it will rise. So hot air rises. As the hot air rises and it goes in the upper atmosphere, it will cool. And remember, I'm going to focus on the northern hemisphere. So as it cools, it's going to sink. So it's going to move away from the equator and it's going to sink. So it comes down here. As the air moves in this region here, this creates a low pressure because the air is moving away from the planet. So imagine you're standing there. There's a little person here, little person. They're standing on the Earth's surface, and the air is moving away from them. So it's a low pressure. And that little person standing here, then all this air is coming down. That's a high pressure, right? And again, that will make more sense as you go through the lesson. So as the air is coming down to the Earth's surface, squashing that person, you're not being squashed, you can't feel it, then the air has to go somewhere. So where is it going to go? As it's sinking here, I'll just draw this as cold air. As it's sinking, and it hits the Earth's surface, it has to go, well, it can feed, this high pressure can feed to this low. So I have a high pressure here. I have a high pressure here that's coming back to the Earth's surface, and I have a low pressure here. Air always moves from a high pressure to a low pressure, and that's something you'll learn in the lesson. But here I am showing you high pressure to a low pressure. But the air can also move in a different direction as well. It can move in this direction as well. Right? Because it hits the Earth's surface, it can go from this high to this low, or it can go up. All right, let's jump up here to the poles. So at the poles, is it going to be hot or cold at the North Pole? And I think it's kind of an obvious answer. So the air, if it's hot or if it's cold, is it going to rise or is it going to sink? And you'll probably say it's going to sink. All right, so this sinking air, now, question. This sinking air at the North Pole, will it move north or south? That is a trick question because it can only move in one direction. It can only move south. So here's my air moving south. So this air at this particular region, because it's coming down, is a high pressure. This air is moving south and this air is moving north. And when the two hit each other, they will move up. It's the only way they can go. So we end up with a low pressure in this area, the 60 degrees. So let's follow the line here, right? Now it's gone up, which way will it go? It can go either way. It can go either in this direction or it can go in this direction. So I'm going to use my yellow here, yellow, to represent what's happening. So I'll just draw a little air thing here. So the sun heats the air at the equator. It rises. It cools, it sinks, it moves north, it hits the downcoming air from the North Pole, and it goes up. It moves towards the North Pole, it sinks. It moves down to the 60, goes up, down, and that cycle continues. So that means energy that's at the equator can be transferred, thermal energy, up to the North Pole. And this is important because if this energy is not transferred, then the North Pole and the northern climates would be much colder. Energy from the equator and the tropical region is transferred to the polar region, and then cold is moved from the polar region down to the tropical region. So it's a great little system that we have here. These geothermic winds, so these are big giant winds here. So these geothermic winds, that's what they're called. Geothermic winds are a result of convection. And you'll see that in the lesson. So these are big, giant convective cells. Each one of these represents a cell. So there's, 3 different cells here. And you'll see the same thing on this side and the same thing in the southern hemisphere as well, right? So this is how energy, thermal energy, is transported through the atmosphere. But we're not done. The Earth turns. And because the Earth turns, because it spins on its axis, you're going to learn something about Coriolis. So I'm not going to teach that to you here. You're going to learn about it in the lesson. You're going to watch some videos and hopefully it'll make some sense. It's an abstract concept. It's a little bit difficult to grasp. Have you ever flushed the toilet and noticed the water always goes in the same direction? That's not because of Coriolis. Notice how the water always drains a certain way in the sink? That's not because of Coriolis. Coriolis only works on very big global stretches of the planet. And oceans and atmospheres are examples of those big giant stretches. So because the Earth is turning, if I were, let's say I was in Toronto, right? Let's say I was in Toronto. I'm going to grab the thing of the world here. Globe. And I'll grab an image. And I should really use Google Earth. That's probably better. Maps. All right. So let's say I'm here in Toronto and I want to fly to Florida, right? So what I would do is I would hop on if I was in a train or a car, I'd hop on the interstate, I-75 or I-79 or something like that, and I would drive straight to Florida in a straight line. Easy, right? I'll just move this out here, go up here. So I drive in a straight line from Toronto to Florida, easy. Pretty much straight because I have to go around, the lakes, but us take these and I'll go down to Florida. However, let's say I fly. Okay, so if I fly and I use blue here to represent my flight, if I decide to fly, well, if I fly in a straight line, well, what's going to happen is because the Earth is turning, Florida is not going to be where I want it to be. Florida is actually going to move because the Earth is spinning. So Florida will end up over here. Oops. Florida will end up over here somewhere, and I'll miss it. I'll end up somewhere in the Gulf of Mexico or in Mexico. So what has to happen is the pilot has to aim for this area, and then by the time they get there 2.5 hours later, Florida is moved, the Earth is moved underneath the plane. The plane is not attached to the Earth. So therefore, it is going to have this effect where it's going to appear to be moving in a curved line, depending on your perspective. And this idea that things that are not attached to the Earth will move is something that we call Coriolis. And so what we see when we start looking at these climatic events here is because the Earth is moving, everything in the northern hemisphere, we expect when you're going from 30 to 0 that it's going to go in this direction. That's what we expect. It should go down. It's black here. It should go this way, from 30 to 0. But because the Earth is moving, in the northern hemisphere, everything is deflected to the right of the direction of travel. So that means it's actually going to look like this because the Earth is spinning. And as the Earth rotates on its axis, it's going to appear to move. So everything between 30 and 60, those big giant winds, they're not going directly north to south. They're tilted. And these winds here are called the northeast trades. The northeast trades. Northeast trade winds. And so if you were a sailor and you relied on winds to get from point A to point B, you need to know this information because that's the prevailing winds. The prevailing winds in this part of the world, that's the direction they move in. And then the winds in our latitude, so we're around 44 or something in the 40s. See how it goes from high to low, from south to north? So we expect it to move like this, but it doesn't because the Earth spins on its axis. So everything always goes to the right of its direction of travel in the northern hemisphere. So it's going to appear to go in this direction. So the winds in this region here, we call them westerlies. So westerlies move from west to east. And so when you're looking at our weather, if you're trying to figure out what is happening, where our weather's coming from in Brampton, in Toronto area, what we'll do is we'll look at the weather to the west. We'll see what the weather to the west of us looks like, and then we know that that's likely going to be our weather soon. There's other things that might affect the weather as well, but we generally look to the west because we're dominated by westerlies. And then finally, when we're looking at from 90 to 60, once again, you'll notice that the wind is moving from directly, we expect to go directly north to south. But because of the Earth's, the way it rotates, it moves in to the right, moves to the right. Okay, and at the poles, it's a little bit odd because of just the nature of how the poles work. But up in the poles, we call those winds the polar easterlies. Okay, the polar easterlies. Polar easterlies. And so that is your explanation. I've now, in this question here, I've used convection, I've talked about the sun, I've talked about Coriolis, and I've used these concepts to explain how the wind moves, how thermal energy is moved from around the planet using winds. And you're going to also learn about ocean currents. These same winds are a huge factor in how ocean currents will move. And as you go through the lesson, make sure you make that connection. So see what I've done here with this diagram, how I've explained this diagram and I've talked it through. I'm asking you to do the same thing. So when you're looking at your major end of the week learning, you can explain this, to try to do it in point form or paragraph, but if you're looking for the yellow or if you're looking for the purple, the exemplary learning, that end of week, then you could consider drawing like I have on an interactive whiteboard, or just on a pen, using a pen and paper is probably the easiest thing that you can do, and explain that concept. That's what I've done here. So I've just demonstrated what I like you to do. And if you can explain it, then you understand it, right? You're teaching it to me, right? You're teaching it to me asynchronously through the power of your video. So good luck with the concept. You have the worksheet to work on. And if you have any questions, please ask.